Hi guys, this is Che. I'm doing homework 5, problem number 2. The question is, given that f xy is equal to 1 over a times x squared y, x is larger than or equal to 1, and y is larger than 1 over x, but smaller than x. So the first part of the question is to draw the non-zero definition region of fxy. Okay, so this is our axis, the y-axis. 1 over x will be something like this, and y equals x will be like this. So so this part here will be y that is larger than 1 over x, but it also has to be smaller than x, so it has to be under this line. So the region here is what we're looking for. And now we're doing part 2. To find a so that fxy is a valid joint density function. In order for this function to be valid, we need to take the double integral of the function, and the result has to be equal to 1. So let's do double integral fxy dy dx is equal to 1. We put dy first, so it's just easier to do the math. And we have double integral over a x squared y dy dx equal to 1. Y is from 1 over x to x. X is from 1 to infinity. Because we're proving if it's 1. So let's do this. So we take the inner integral first, and we get let me see. Because we are y is the variable now, so we can think of a x squared as a constant, and we take it out of the integral of the second integral, and we have 1 over y dy dx. And 1 over the integral of 1 over y dy is just the natural log of y. So we have this, the constant natural log y from from 1 over x to x dx. 1 integral ax squared natural log x minus natural log 1 over x dx. And this is natural log a minus natural log b is natural log a over b. So we have natural log x over 1 over x. It'll be natural log of x squared. And this can also be written as as 2 natural log x. over ax squared dx. And now in this integral, x is the only variable, and we can think of 2 over a as the constant now. X squared natural log x dx. Here I use the integral table, and this is equal to negative natural log of x plus 1 over x from 1 to infinity dx. Wait, no, just that. And now to make this a valid joint density function, we need to make this whole thing equal to 1, right? So what we have here, when we plug in infinity into the radical here and 1 into x, we get 2 over a when we plug in infinity, this whole thing will be 0, because when x is larger and larger, it becomes, if we draw a graph, it will be smaller and smaller and will approach 0. So we get 0 for when we plug in infinity, and then we have minus natural log 1 will be 0, right? So we have 0 plus 1, so we just have negative 1 over 1, and this will just be negative 1. And so we have positive 1 here, and this is equal to 1. So we have a is equal to 2. Okay. And what's the next question? Okay. So the next question is to find and draw the marginal density function fx and fy. So we do fx equal to so we get a equals 2 from the last question. We get fxy equals to 1 over 2x squared y. Right, and x is larger than 1. Y is larger than 1 over x but smaller than x. So now we do f of x. We have f of x equals to the integral of 2 yx squared dy. And then we have, because y is the only variable, just like what we did for the last problem, we can take out 1 over 2x squared as a constant. So this would be L and y, right? And L in the range for this integral is from 1 over x to x. So this will be from 1 over x to x. And we will get 1 over x squared ln x minus ln 1 over x will be ln x over 1 over x. So be natural log of x squared, which is 2 natural log x times 2x squared 1. And we have natural log of x over x squared. And this graph will be something like so we have a point here when x is 1, natural log of 1 is 0. So when x is 1, we have f of x equal to 0, and this graph will look like this. And as x goes to infinity, the f of x is approaching 0. And for f of y, we have for f of y, we have to do it in 2 cases. That is when the first integral will be taken from 1 over x to infinity to y x squared dx. And this will be same thing here, to 1 over this negative 1 over x from 1 over y to infinity. And when x is infinity, it's just 0. So we have 0 minus a minus here, we have positive 1 over 2y times y. And this will be 1 over 2. And now for the second part of the f of y, we have this from integral taken from y to infinity. Take out 1 over 2y as the constant. We have integral 1 over x squared